All right. It's up 1:15, so let's get started. Hi, everybody. Hope you're hearing me well. And welcome to today's webinar on React Concurrent Mode and data fetching with Suspense. This webinar is kindly hosted by Edument. My name is Marc. I'm a developer and teacher working a lot with React. Among other things, I teach React courses that Edument offers, React Foundation and React Advanced. And in this webinar, we'll be exploring the upcoming features in React known as Concurrent Mode and the special feature in Concurrent Mode called Suspense. Before we get started, you're noticing that I'm conducting this webinar in English. That's because we have a few non-Swedish speaking members of the audience. The code for today's talk has been shared in the chat, and you'll also get the link for the code along with a link to an article that delves deeper into the material presented today in an email that Edument will send afterwards. And at the end, we'll have time for questions. So if you think of any, you just type them in the chat and I'll go through them at the end and answer them as best I can. So let's get started with introducing what concurrent mode is. The purpose of concurrent mode, as elaborated on by the React team, is that we as app developers ought to be able to deliver the best user experience possible that aligns with the resources of the device that the end user utilizes. Meaning, as the user, or depending on the user's CPU and network speed, we should be able to gracefully scale our apps and, most importantly, be able to stay responsive at all times. What does that mean in practice? Well, the resources of a user's device can roughly be divided into partly computing power and partly I/O-related issues, such as network speed. So if we start looking at things from the CPU side and try to understand what the meaning of concurrency is, I think it's the best if you start looking at concurrency from the way React behaves today, which is in a non-concurrent mode. So imagine that we have an input box in our React app where the user can type some text, and as the user types text, the input field is updated with that text, and a lot of other things on the page are rendered as well. Maybe we filter through a long list of items, or we update a few intensive graphs. Basically, we are listening for an onChange event on our input box. As the user types text, we perform a state update. We update the state in our component, which in turn re-renders the component, and along with that, say, a few graphs or a long list of items. Now, when React performs this operation, it does it in a so-called blocking fashion. What does that mean, blocking the rendering? Imagine that we designate the code in our onChange handler as one task and the rendering process as a separate task. So we have two tasks with basically the same priority. We'll listen for something to happen in our input field, and a slight moment afterwards, we re-render the page. These tasks, the onChange, listener, and the rendering process, currently have the same priority. React doesn't distinguish between them in terms of importance. So they have the same priority, and they render, or they occur in sequence. And this means that we have a non-concurrent mode of operation, where we would really like to pay more attention to unchanged tasks rather than render tasks, because the render process blocks everything else. Remember, the web browser is a single-threaded environment, which means that if we type something into the input box and that in turn leads to a long rendering process, we're blocked. We cannot enter any more text. Maybe we have spinners or animations that would suddenly block as well. So this becomes a problem very, very quickly. To show this in action, let's look at a quick demo. Here I have the case I just mentioned. I have an input box and I have two graphs. And as you will see, as I enter text, in the beginning, it seems to update pretty much synchronously, but very quickly, I become blocked in my typing and rendering. So let's see what this looks like. I hope everybody noticed that it took just a few keystrokes and then it became completely blocked, both in terms of entering text and updating my graphs. Let's try that again. Yeah. So this is a relatively simple app, but we immediately run into problems. So what are some ways around this with React currently? Well, there aren't too many, actually. There is something called debouncing, which simply means that we don't try to render as fast as we can. We try to delay the rendering and let the user enter text. And after a certain period of time, if the user doesn't enter more text, then we render. And there's a close cousin to debouncing called throttling, which simply means that we always schedule re-rendering at certain intervals. But though both of these solutions are at best stopgap measures, they don't really solve the problem of React working in a non-concurrent fashion. But ideally, we would like to have concurrency in our app. Specifically, that's something that scales well to the resources and capabilities of the end user's device. Meaning, if we were to have a fast device, well, then we would like the rendering to be more or less immediate. We type text and we see the updates immediately. But on a slow device, maybe we won't get an immediate update to what we entered in the input box, but at least we are maybe able to stay responsive. And when I say responsive, I mean I type text and my graphs may lag behind my typing a little bit. They will always update, but they will lag behind a bit as I type in more text and more complicated things get rendered. This is an okay compromise for my apps. Otherwise, as you just saw, we're just constantly blocking the user as we get more and more complex things to render. So this last part where we are able to scale gracefully, as the goal is with concurrent mode, is something we can observe in the next demo. So here we have the same demo again, but this time we're running in React's concurrent mode. We have activated it. So try to pay close attention to what happens in the input box as I type text, and then how fast the graphs render as I type. So you may saw that I was able to type text quite well. I didn't block on the input box, and the rendering that occurs as a consequence of me rendering over typing text, they were lagging behind a bit. So you saw basically a lot of state updates occurring in quick succession as I was typing. So, but my typing, this is the most important, always gives me basically an immediate synchronous experience. Whereas something that is maybe a little less important, meaning my graph updates, they lag behind. And this is what concurrent mode enables me to do in a concurrent fashion. I just want to delve into what we just saw and try to analogize it a bit. Imagine that we are working with a Git branch. So we have a master branch where we are able to push updates. And this first branch, I call it master, the master branch. And it represents what I do to the input box. Basically, whatever text I type into the input box, those updates are reflected on the master branch. And as I type text, I start to conduct work on a feature branch or a separate branch. And this work correlates to my graphs. So the first master branch is related to my input, and the separate branch is related to my graphs. And as you saw, my master branch always gets updated immediately, but after a while, so as I type text, I get more and more updates, but after a while, it's time to update the page with whatever the graphs are supposed to reflect. So you can imagine React simply performing a rebase, a git rebase. So I type text, I perform updates, and at some point in time, React decides to let's rebase, let's merge these branches together. And I get a final branch, final master branch that looks like this. I'm sorry. There's supposed to be there. With the following. We performed some inputs, we performed some tasks on updating the graphs, and after a while, React decides to perform a rebase and simply merges these two branches together, so we get a final update that reflects my typing, and the graphs show me the result. And then we actually flush these changes to the browser DOM. Now, what you see here, performing on the separate branch, it all occurs in the background. We don't actually see it. All we see is the work performed on the master branch, basically whatever I type in the input. But this work is performed in the background. And that implies that this work, these tasks performed on the separate branch, have a lower priority. We can see this more clearly if we profile our code. So if you have the Chrome DevTools extension enabled, you have the ability to profile your code. So let's see what we get by profiling this code. So let's start a profiling session. Let's type in some code. And then stop the profiling. Hopefully everybody can see this graph here with a few bars. This represents my inputs, whatever I type into the box, and my graph updates. So you can see that we have a lot of bars, and this represents the time it takes to render each state update. So as I type text, you see that I only seem to be updating my input box. But at some point in time, I start to update my graphs. And these graphs, they have a lower priority than the task of updating my inputs. So here, for example, we have a bar that is green. It has a priority of normal, whereas maybe this bar that we can't even see has a property of user blocking. So everything that has a property of user blocking is related to my input and updating the text in my input without blocking me. But at some point in time, React decides that it's time to update the graphs as well. And then we get bars with a priority of normal. And you can see there's a lot more happening when such an update occurs. And that is because we have to render a lot of components in our graphs. So suddenly we have tasks having different priorities, and React is able to schedule them at appropriate times to enable us to have a concurrent experience for our users. So hopefully this gave you an overview of how we can build very responsive apps quite easily with concurrent mode. The code behind this, you can explore this by yourselves. It's not too complicated, and it's well documented by me. But basically, with a few changes to our component code, we can achieve an experience that otherwise is really hard to realize with the way React works today. So that was a short overview of concurrent mode. Let's delve into the main topic of this talk, which is React Suspense. And Suspense is related to the second type of resource that our end user's device has, which is bandwidth, basically. And we know that slow networks, well, as we have to load a lot of data, typically in our React apps, if we are on a slow network, or the bandwidth is limited, often the loading experience can be quite bad. And we currently don't have too many tools to improve upon this experience. And to show this in action, I was planning to use a demo again, namely to demonstrate what a bad loading experience is, but what you typically find in a lot of React apps today. So here you have a very simple app that lets us display GitHub info for different users. And try to pay attention to what happens as I click on a user and the loading sequence and thereby experience that you witness. Hopefully that was sort of visible. Let's take another one just to repeat what we see. So this experience is often as good as it gets today. And it doesn't maybe seem all that bad, but it's actually not far from what we can, or hopefully would like to achieve. First of all, data arrives at different speeds. So here we saw that the data for repositories and followers seem to arrive earlier and were rendered earlier than the profile info, which is the image and the user's name. So we saw these occurring and being rendered first. Then we were awaiting the profile info, where we got the name first, and then the image, which pushed down the name. So the whole experience was quite janky, wasn't synchronized at all. Things just appeared and were rendered in the order that the data arrived. And also, we simply turn into this profile view immediately, showing loading spinners. And this is often the thing that we try to avoid showing users, too many loading spinners, because they can be quite irritating and annoying. So we would like to be able to minimize those spinners, try to sync the experience a bit more so we don't have things jumping up and down all the time. And again, the way we do this today is, well, it's hard to achieve this experience. If we look at the code for the things that were rendered right now, again, all this code is available through the link on GitHub. But basically, when we render the profile view, we're rendering a user component, we're rendering a repositories component, and a followers component. But these components simply render, and they start fetching independently of each other. There's no synchronization going on between the user and the repos component, for example. And if we look at the user component, sorry, in the correct directory, if you look at the user component, here I'm using a third-party hook to fetch data, but you can see that the loading spinner is being rendered by the user component itself. So we have an if statement that checks if the data we would like to render has been fetched yet. If it's not, if that hasn't arrived already, we try to show the user on a loading spinner. And once we actually get the data, we re-render the user component with the data that we received. But again, there's some code related to showing spinners in our user component. And that's maybe not the most ideal code to have. But we'd like to maybe have a more cleaner code in our components. So that was the state of loading things today. Maybe sometimes you can try to load as much data as possible before you render, but then you just delay the experience for the user. And so that's not ideal as well. We could have loaded all the data related to the user and the repos and the followers at once, and then only then show the entire profile view for the user. But again, that would delay if data were to arrive at different points in time, we would simply delay everything. So that's not the most ideal situation either. So let's take a look at what an improved loading experience can look like. So clear out my cache, and let's see what happens when I click on a user now. Takes a little while. Boom. So you saw that things took a while to load, but we anticipated it in a way by showing an indicator. So instead of just switching to this view directly, we remained on the previous page or in the previous view, and only when everything has been loaded is the point in time when we switch over to this profile view. And now we saw that everything was shown at once, the image, the name, as well as the repositories and the followers. Let's try to look at an additional example. Again, everything is shown together as one big unit. If you ask me, this is a way superior experience, because we're telling the user something is about to happen, and we await the data to arrive, and only then do we show it. And suddenly all the loading spinners have been erased. And it actually feels, according to a lot of research, that this experience feels faster than the previous one, where everything just occurs with spinners and being rendered haphazardly. And this is the experience that Suspense allows us to achieve. So let's look at a bit of code to see where Suspense comes into place. So here I have the code again for rendering a user component, a repos component, and a followers component. But now, in contrast to the previous example, I have added what is called a suspense boundary around my user, repos, and followers. And I have a state variable called show profile, meaning that when I click on a user and the show profile flag turns to true, that's the signal to React to start to render this markup, these components, and then show it when it's ready. And this ties back into what we talked about in terms of concurrent mode and things happening on separate branches. When I click on a user and a pending indicator starts showing the 3 dots, what React actually does is it tries to render all of this in the background in a separate branch. And only when everything has been fetched and we are ready to show the profile view with the user's profile info, repos, and followers, that's when React merges the separate branch with the master branch. Again, the master branch is the one where we're showing a pending indicator. And once the branch with the profile view has been completed, meaning we have fetched all the data, we have rendered everything, then we rebase, then we merge that branch with the master branch, and we see the profile view. So again, the way that React now structures its rendering process enables us to perform work in the background, hidden from the user. And only when we deem it's necessary, when we're done, it's when we then turn and display the things that was the work that was performed in the background. So this improves on the previous example quite a bit, in my opinion, and I hope in your opinion as well. But there are some things we can adjust here. For example, we could decide that the user profile info is the most important info to show first, meaning if we get the avatar URL and we get the name of the user, let's at least try to show that together as soon as possible. The repos and the followers are not as critical in terms of information to show as the profile info. So if we could just simply let them, let's render them whenever they are ready, but make sure to show the user profile info as soon as humanly possible. That would sort of allow us to see things sooner rather than later. So if we want to delay or simply let these components perform their work, but switch over to the profile view to at least show the profile info, the image and the name, we could wrap these components in their own suspense boundaries. So we could simply wrap the repos component in a suspense boundary. And we could do the same for the followers. So now we have three boundaries, one outer boundary that covers everything, and two inner boundaries that simply wrap the repos and followers components. So let's check out what that results in. That was quite fast actually, but it seemed to load faster this time. And we display things as soon as possible. So this part of the page of the view will show first, and if these take longer, well, then they take longer. I can adjust my, I have a slight delay in my code to just demonstrate this. So let's try another user. That was maybe clearer. So now you see we display the profile info first, and these take their time, but they're not as critical to the user for me to view as this part. So this enables us to construct loading sequences and schedule them in a way that is optimal for our app with very little code. Again, this was all accomplished with the use of 3 suspense boundaries. So the Suspense API gives us a component called Suspense. We can wrap certain component code in such boundaries. And this allows us to determine what the loading sequence of our app should be. We can adjust this for different pages or views. But this is a very powerful construct for us to use, and something that is not available today in React. So hopefully this gives you an overview of the possibilities that Suspense opens up for us. But again, all of this is built on the same premise, that we can perform work in the background, and only when that work is completed, then we switch over and render it. And you can peruse this code on GitHub. But basically what I do is when I select the user, I start a so-called transition in React terminology. So a transition starts I even start to fetch my user profile data as soon as possible, and then I set my show profile flag to true. But everything that happens as a result of this code, meaning set my show profile flag to true, means that everything that happens will be happening in the background. Again, I cannot stress this enough. We don't see those things happening in the background until a little while later when it's completed. As a final thing, I would like to show you what happens to these fallback props. You can see that I'm using something called a fallback, and I'm passing in actually a component to show, but to show when. Well, if I delay this transition or delay the fetching a little bit, say by 7 seconds, you can try to see what happens. So we saw a slight loading spinner or loading fallback being shown before we display the profile view. I have a timeout here. If the transition, meaning the work I perform in the background, takes too long, in this case more than 5 seconds, I'm telling React and the suspense mechanism that I have a fallback to show. That's because if I show my pending indicator too long, the user might think that my browser has freezed, and that's not ideal either. So we can have trade-offs between showing the pending indicator, but if things take too long to happen in the background, I switch over to my fallback just to let the user know that something's actually occurring. And then finally, we'll see the complete profile view after a while. Again, you have a lot of flexibility in how you determine what the user gets to see, but everything is, we are able to declare this with ease to provide the best user experience. So again, I describe all of this more in detail in an article that is published on Edument's site. We will get this link in the email that is to be sent out after this talk. And it will explain what happens in the start transition method and more about the Suspense API to allow you to experiment on your own with these constructs. But keep in mind that in a way, React is giving us a lot more opportunities and abilities to do more interesting work and to build more powerful user experiences. But things are about to become a bit harder as well. The notion that you can have things being performed in the background and then switch to the foreground on different branches, so to speak, this is all something that we'll have to incorporate into our thinking when it comes to web development, web app development in the future, because these types of experiences that we would like to build are hard to achieve or hard to implement if we don't start to acquire the mental model of concurrency in our web apps. Those of you who have worked with maybe a low-level program before within the backend, you already are familiar with these types of concurrent constructs. But these are just starting to make their appearance on the front end as well. So this is a peek into what web development in the near future will look like, irrespective of the framework you choose to use, whether it's React, Vue, or Angular. All of these frameworks or libraries will have some sort of concurrency API for us to work with. All right, that was my brief introduction to concurrent mode and suspense. I hope that you've been enticed to explore this further. And I think now maybe we can look at some questions if any one of you are wondering about something that we just went through. I should also point out that all of this is actually still in an experimental mode. So it's not officially released by the React team, by the Facebook team. It will find its way into a stable release shortly, though with all things happening in the world right now, I'm not sure what if they've changed the roadmap a bit, but expect this to become a public API for us in the stable branch of React pretty soon. It has taken over 2 years to get it right. So I've been waiting for a while. But this is something that is pretty much, the API is pretty much stable. So you can get started right away on a prototype or maybe in a certain piece of your projects. And there are third-party libraries that also incorporate support for Suspense. So Suspense doesn't really tell us how we fetch data. That is still up to us. But it enables us to simply tell React when it's time to pause and resume rendering and perform stuff in the background. So I should also mention that Facebook is using this on facebook.com. So don't be afraid to start utilizing this, because it's been battle tested on perhaps one of the most intensive web apps found today. And there are some questions about if we can use this to mock or show mock data before we actually show real data. Yeah, you can. I've been very sparse with my fallback information and my pending indicator, but you can display anything as you're pending for the background work to be displayed. So if you would like to add more information, maybe dummy data, that is completely up to you. At some point in time, React would switch over to whatever was rendered in the background, and during that period when you're waiting or the user is waiting, you can show pretty much anything that you desire. So yeah. And I should also say that Suspense, I've used this now for JSON data, basically, API requests and getting back JSON data. But you can use Suspense and to wait for stuff to arrive, no matter what asset we're talking about. Suspense is also used for loading chunks of code. If you use code splitting, you can wait for images. So actually the image that we are waiting for in our profile view is also fetched in this manner. So we can wait for it to arrive and sync its rendering with the username. So it's actually not something that tells us how we fetch data or what data to use. So there's a lot of flexibility in what type of content you're fetching. What I haven't displayed here, but is available in the code on GitHub, is what happens if an error occurs. So what happens if we fail, for example, to fetch data pertaining to the profile info for the user? Well, when we use the standard mechanism that React gives us, which is an error boundary. So error boundary is the main construct we have in React to catch errors. So if we get something that an error occurs during the fetching of a user, that error will propagate up to my error boundary. And then perhaps I can have a refresh or retry button maybe, which tries to do this again in the background. But an error simply will be caught by an error boundary. Just as you're hopefully using error boundaries for other purposes in your app. But you need a suspense boundary for waiting for the content that each component here starts fetching, enabled to orchestrate your loading sequence. It's a very good question. I get that often. So, and that's a good reminder to use error boundaries. I sometimes see that a lot of people miss that and try to work with errors other ways. But our error boundaries for the win in your React apps. Great questions. Just as to indicate that this is not just in an experimental stage, I have a fifth example, which you can also look at on GitHub, where I'm using a third-party library. I'm using something called React Query. And React Query is shipped now with Suspense support. So you can use it for production purposes. In my project, I'm using React Query and their Suspense integration. So I can achieve the functionality displayed in my demos in my production app as well. So try to look at a few third-party libraries. React Query is one of them. There are a few others as well. But React Query comes with a lot of good documentation. So, all right. Any more questions? We have a few more minutes. I think the big takeaway from this talk, well, part of it is the new API that we have available in React. But again, I want to stress what we will expect our code to look like and how it will work in the near future. Again, we don't have multiple threads in our front-end code, but something that is reminiscent of that, namely the way we achieve concurrency, is something we will have to think a lot about. Hopefully, we'll have all the tools we need for it stable soon, Concurrent Mode, Suspense. But I would recommend to brush up on a few concurrency-related themes and issues as you try to incorporate these constructs in your own apps. Yeah, a question about code splitting and React Lazy. Yeah, so let's see if I had my... Here you have an example of Suspense being used for code splitting and how to load something that is a code chunk. So maybe some of you have started to code split your apps or about to. So React has had code splitting and lazy loaded components for a while, where you use something called React Lazy to basically designate what component to separate out to a separate chunk that is loaded on demand as we render it. So in this case, I have an app component, and whenever it's rendered the first time, I fetch it lazily, and then I render it. And this is actually the first scenario where Suspense came into play. As you can see, I'm also using the Suspense component here with a fallback. And Suspense has been active in React since 16.6, but for this special case only, loading component code. So basically now they have extended Suspense to incorporate any type of content besides code chunks. But the same approach that's used for code splitting is used for fetching anything else, basically, as you've just seen. So now you have one way to fetch everything in a suspenseful manner, so to speak. And I should also say that React is trying to come up with patterns for not only loading data and code with Suspense, but also trying to parallelize everything that is possible. So I've only shown you right now, or besides this example, that we load data with Suspense, but we want to load data as soon as possible. So in the future, you'll have to also pay more attention to how you code split and actually incorporate more code splitting into your apps. Because we code split our components, we can get the time to first byte for our app will improve. And as we load code, we'll often also know what data that is related to that code. So if we have a home component and we have home component related data, as we start to fetch that component lazily, we can also start to fetch the data for that component lazily as well. So we'll see more code splitting and more data overall being fetched this way with Suspense in the future. React Relay, the GraphQL server that Facebook is built on, has a lot of information about how to not only load data with Suspense, but also code. So code splitting and loading data with Suspense go hand in hand. So that was most of my content that I wanted to show to you. Again, please reach out to me. My email is marc@remotify.com. So this is my email. You'll get that in the email link that we'll send out to you. So if you have any question about Suspense or Concurrent Mode, or maybe React overall, I'm happy to answer any questions, because I'm interested to hear your questions and the challenges or fun React adventures you're about to embark on. So hit me up with anything. Again, the code is available on GitHub with a lot of comments and explanations. Hopefully that will cover more if you think of any more questions related to this. So thanks for any feedback. I'll take that to heart and make my next webinar even more interesting, I hope. So with that, yeah, we reached the end of the time slot, 2 o'clock. Again, I thank you. Hope you had a good time listening to the latest about React, and have an amazing day. I'll hopefully talk to you soon. Thank you.